Hello students, I am Meenu, Assistant Professor in GCW Bhavani Kheda. In the last lecture, we have studied about SR flip-flop. Now today, we are going to discuss about the next flip-flop, that is JK flip-flop. Due to undefined state in the SR flip-flop, another flip-flop is required in electronics, which is known as JK flip-flop. Basically, JK flip-flop is an improvement on the SR flip-flop. The JK flip-flop is named after Jack Kilby, who is an electrical engineer who invented integrated circuits. Basically, the main problem which was occurred in SR flip-flop when S and R have value 1, then it will give undetermined state, which is overcome by JK flip-flop. In the JK flip-flop, when the input condition of JK equals to 1, it will give an output inverting the output state. However, the outputs are same when one tests the circuit practically. Now we can see with the help of an diagram. See here, this is the diagram of the JK flip-flop. Now in the truth table of JK flip-flop, when the input value of J and K is 0, 0, then it will give the Q0 state, that is no change in the output. And when JK value have 1 and 0, it will give set state. And when the JK value is 0, 1, it will give 0 state. It is same as an SR flip-flop. But when JK value have 1 state, input state, then it will give the toggle state, that is Q complement state. But in SR flip-flop, it defined an undetermined state when S and R value have one input value. This is in this JK flip-flop, we overcome the problem of the SR flip-flop. But in JK flip-flop, there is a condition called race around condition occurs. For the JK flip-flop, if J and K and clock are equal to 1, the state of the flip-flop keeps on toggling, which leads to uncertainty in determining the output of the flip-flop, which is called race around condition. This race around condition can be overcome by the master-slave JK flip-flop. In the master-slave JK flip-flop, if the flip-flop is made to toggle over one clock period, then racing around condition can be eliminated. See, with the help of the diagram, in the master-slave JK flip-flop, we join two JK flip-flop. First one is master slave flip-flop, second one is slave flip-flop. Now we provide the clock pulse to each flip-flop, master flip-flop and slave flip-flop. But when the clock value is 1, then master flip-flop will be activated and the slave will be disabled. And when the clock value is 0, then master flip-flop will be disabled and slave flip-flop will be in active mode. It means it will start working. When for the entire clock pulse the master will work and the slave disabled, then we overcome the problem of race around condition in the JK flip-flop, because in the JK flip-flop, in the clock pulse every time the value will get toggled, but in the master slave flip-flop the value can't be toggled in the entire clock pulse. Now we have next flip-flop, that is D flip-flop. Basically, D flip-flop is better alternative that is very popular with the digital electronics. They are commonly used for counters and shift registers and input synchronization. In a D flip-flop, the output can be only changed at the clock edge, and if the input changes at other times, the output will be unaffected. Now here's the diagram of the D flip-flop. In the D flip-flop, when the input value of D is 0, then we get the output is 0. And when the value of D is 1, then the output will be 1. See, with the help of this diagram, basically we can combine the D flip-flop with the JK flip-flop. In the JK flip-flop, we can give the input as D with the inverter to the K input. When the value of D is 0, it means J have value 0 and K have value 1. Then we have already studied in the JK flip-flop, when the J is 0 and K is 1, then the output will be 0. And now when value of D is 1, then the value of J is 1 and the K value get inverted as 0. And when the J and K value have 1 and 0, then it will give one state, that is set state. So in the D flip-flop, when we give input 0, then output will be 0, and when we give input as 1, then output will be as set state, that is 1 state. This is all about D flip-flop. Now the next flip-flop is T flip-flop. In the T flip-flop is basically just like the JK flip-flop. These are a single input version of the JK flip-flop. This is modified form of JK flip-flop is obtained by connecting both input J and K together. This flip-flop has only one input along with the clock input. These flip-flop are called T flip-flop because of their ability to complement its state, toggle. Hence the name toggle flip-flop. Basically T flip-flop is named as a toggle flip-flop. In the T flip-flop, we directly give the input value to the J and K. As we earlier see in the D flip-flop, in the D flip-flop, we give the input as inverted in the J and K flip-flop, while in T flip-flop we give directly input to the J and K flip-flop. So when the value of T equals to 0, it means J equals to 0 and K is also equals to 0. And when J and K equals to 0, then it will give Q 0 state, that is no change will be occur. The value of the previous output is same as the value of the next output. So here when the value of T is 0 and 0, then the next state will be 0 and 1. It will depend on the previous state. Now when the value of T equals to 1, then it will give the complement state. Complement state means that is Q0 complement. It means the output of the T flip-flop when T equals to 1 will be dependent on the previous state of the Q, as it will toggle the value of Q when the input value of T is 1. Then see here the value of 0 value will be toggled, that is from 0 to 1 and from 1 to 0. Okay, so here if we draw the truth table of the T flip-flop, then when the T value of input is 0, then it will give as output to Q0 normally, and when the value of T equals to 1, then it will complement the value of Q0. Okay, this is why it is called toggle flip-flop. There are many applications of the flip-flop. There are various types of flip-flop being used in digital electronics, and the applications of flip-flop are specified below. As flip-flop are used in counters. First one, counters. Basically, the groups of interconnected flip-flops are used as counters to count the increment or decrement of an event occurrence. And second application of the flip-flop is frequency division or frequency dividers. As flip-flops are used as frequency division circuits, which divide the input frequency to exactly to its half. Frequency division circuits are used to regularize the frequency of the electronics circuit. Now, third application of flip-flop is shift registers. As the flip-flops have two stable state, okay, we use them in memory elements like registers for data storage. Generally, we use register in electronic devices like computers. And fourth one is storage registers. As I told earlier, that is, it is used, flip-flop has two stable state. We use them in memory elements like register for the data storage, and it is also used for the data transfer. We use shift registers to transfer the data from one flip-flop to another, which are connected in a specified order. So these are the main applications of the flip-flops, that is counters, frequency dividers, shift registers, storage registers, and also for the data transfer. This is all about the flip-flops. Firstly, we have discussed about the what do you mean by flip-flop and the types of flip-flop. And types of flip-flop includes SR flip-flop, JK flip-flop, master slave flip-flop, D flip-flop, and T flip-flop. And at the last, we have studied about the applications of the flip-flop. Okay. Thank you.